What's up, guys? So we have just a couple more exponent rules to go through, and again, the first ones we're going to go through are exponent rules we already have looked at before, and doing what were we doing? We know we did multiplying with the opposite, and so we're going to look at how divide. What do we do when we are dividing exponents? We've done this before when we were factoring, multiplying, dividing. We've done these before. And then we're going to get into some special cases with negative exponents and zero exponents, and of course we know what zero exponents to do. The only new thing really are the negative exponents. But let's look at the quotient rule, which is just dividing monomials. So just like with multiplying, if I go ahead and expand these out in my pen, there we go. So this is x to the 10th. So that is 10 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 10x to the third, 10 cubed, x cubed. All right. We know that if we have pairs at the top and bottom, they equal 1. So 1, 2, 3. We have 3 pairs. All right. So we have 1 times 1 times 1, which we don't have to put because we know that 1 times anything is 1. So we're left with, now we simplify the coefficients, which is going to be 1/2. And at the top we still have 7 x's, so that's x to the 7th. Alright, so you can also write it as 1/2 x to the 7th. So what did we do with the exponents? We ended up with 7. Alright, how do we get 7? X to the 10th, x to the 3rd. So when we were multiplying exponents, we added them. Alright, so if this was x to the 7th times x to the 3rd, you get x to the 10th. So the inverse of that would be to subtract the exponents. Alright, and like we saw, when we match them up, we have 10 x's divided by 3 x's. We're left with 7 x's. So you can simply subtract the exponents. So you're going to divide the coefficients if there are any. And then subtract the exponents. So the second example, slight work. Now remember, if there is not an exponent, there is not 0, it's to the first power. So you have x to the 9th divided by x to the 1st, which is x to the 9th minus 1, which gives us x to the 8th. Alright, here we have coefficients, so we have to divide those. So we got 16 over 4. And then we have x to the 8th divided by x third, so minus 3. And then y to the 5th, which doesn't have a y at the bottom, so we leave it like it is. 16 divided by 4 is 4. 8 minus 3 is 5, y to the 5th. And the last one here, so we have an exponent outside of parentheses. So this is going to have to use the power to a power rule, in which we distribute this exponent to each one. If there's already an exponent there, we multiply them. Alright, we do not add them when it's outside of the parentheses. It's not the same as up here where you have a base like bases and you're multiplying. Here, you're raising each of these to this power, so you have to multiply them. Up here, you just added the exponents. So, at the top, we have 3 cubed, x to the 8th times 3, y cubed times 3, over 9 squared, x squared times 2, and y squared times 2. Then we simplify that. 3 squared is 27. X, 8 times 3 is 24. 3 times 3 is 9. Over 81. X to the 4th y to the fourth. And then we can just simplify that. We know, or should know, that these are divisible by 27. So that's going to simplify. Let me write this down like this. So 27 over 81 times x to the 24th minus 4, since we're dividing, and y to the 9th minus 4. That fraction is going to simplify to 1/3. X to the 20th, y to the 5th. All right. Now, we have the negative. Well, let's look at the zero exponents first. Since we know the rules for zero, we already know that anything to the 0 power is 1. All right, it could be 1,000,000 to the 0 power, that equals 1. So we have 4. Remember, x to the 0 is 1 times y cubed. That's 4 times 1, which is 4y cubed. Easy. Then here, again, we're going to divide the exponent, or the coefficients. 16 divided by 2, y to the 4th minus 4. You can get 8 over y to, or 8 times y to the 0, which is 8 times 1, which is 8. So, we know zero exponents. Alright, anything to the 0 is 1. You just replace that factor to the 0 power with 1, and you multiply. Alright, again, doesn't just disappear, it just equals 1, and anything times 1 is itself. Now with the negative exponents, let's see what happens. So if I do the same thing I was doing before, where I divide the coefficients, alright, then I have x to the 4th. Let me put this all over at the top. It'll make more sense that way. So you have 5 over 10, and then x to the 4th minus 6, because remember, we're dividing. We know 5 over 10 is 1/2, and x to the negative 2nd power. All right. When you have a negative exponent, you're going to move that exponent to the, either to the denominator from the numerator and vice versa. So here we have 1/2. The exponent was negative at the top, so it's going to be positive at the bottom. All right, let's try another one. So here it's just x to the 4th minus 6, so that equals x to the negative 2. All right, now this one is in the numerator. Remember, all fractions are all numbers are always over 1, so this simply becomes, we know this moves to the bottom, but what's left at the top? So we're also always multiplying by 1. So there's still a 1 at the top. So 1 over x squared. So it's a more complex one. So again, still multiplying the exponents, or not multiplying, dividing the coefficient. So you have 16 over 4, and then x to the 12th minus 4, because we're dividing, and we have this y that's negative at the top. We know 16 over 4 is 4. We have x to the 8th, still have this y to the negative 3rd, and remember, since it's negative, it's going to move to the denominator and become positive. Alright, I'm going to write these steps for us. So, if exponent is negative at the top, exponent negative, and numerator make positive in the denominator. And if the exponent is negative in the denominator, exponent. That should just be exponent. Math teacher, not English teacher. And denominator, make positive in the numerator. Alright, so essentially saying if it's negative at the top, make positive in the bottom. So you're going to take it from the negative from the top, move it down, make it positive in the bottom, and vice versa here. If it's negative in the bottom, make it positive at the top. Alright, like we've done these examples. And the last example here, again, power to a power. So we have to distribute that exponent to each factor. So 3 cubed x to the negative 5th times 3. Y3 times 3, and so you get 27 x to the negative 15th, y to the 9th, which leaves us with 27 y to the 9th, and since that x exponent is negative, that moves to the denominator. So on the back of each of these, you're going to do all of the practice problems just because these are the more complex exponent rules, and you will have them on your STAR test with this complexity. Like I told you before, the hardest thing about the exponent rules is not them individually, it's when you have to combine them, and you will see some ridiculous ones, but it's just a matter of doing each rule separately within a problem, but then ultimately having them all together. So if you have questions, please let me know.